Good morning, viewers. This is Kasturi Day. Today, I've come again to discuss the chemistry chapter of class 9 syllabus, ICSE, and that is of language of chemistry, the first chapter I'm discussing in my channel. So I'll start with, before that, I'll tell you one thing that I'll be discussing some ICSE pattern questions are from class 9. Okay. So for that, you need to subscribe with me and stay with me in this channel, and press the like button so that it can motivate me to produce you good videos. And also you need to subscribe and also do share with your friends so that they can also be benefited from these videos. Okay. So in my last video, I discussed about the introduction of chemistry and also the symbols of the elements which are known to us. Okay, now we come to the valency. What is valency? Valency is the measure of the combining capacity of an element with other elements. That is, one element combining with the other. How many atoms of the element are combining with the other element? So that gives the combining capacity, and that is the valency. As no element has a combining capacity less than 1, then the valency of hydrogen. Okay, therefore the valency of hydrogen is taken to be 1 and is considered as standard. See, valency of hydrogen, we consider it as 1, because the valency of any element, the valency, it cannot be less than the valency of hydrogen, or the less than 1. Okay, it cannot be any element cannot have a valency which is less than 1. Okay, and then the valency of hydrogen also. Okay, therefore the valency of hydrogen is taken to be 1, and that is considered to be as standard. Therefore the valency is a measures in terms of hydrogen or oxygen atoms. Okay, in this respect, the valency of an element is the number of hydrogen atoms or double the number of oxygen atom that can combine with it. Okay, so if we consider an element, we want to know the combining capacity of an element or the valency of an element. So if we, for that, if we take if we know the number of hydrogen atoms or the double the number of oxygen atoms that can combine with that element, same element, then we can know the valency of that element. Okay, that for example, if we take one element name, say X, okay, so we need to know the number of hydrogen atoms or double the number of oxygen atoms which are combining with that element X. Okay, then we will be able to know the valency of that element X. According to the modern definition, valency is the number of electrons that an atom can lose or gain or share during a chemical reaction. We know that in an atom, the outer orbit will have the valence electrons. That is, from that shell or orbit, the electrons are either taken from some other element, or they are given to some other element in a chemical reaction, or they can be shared also during a chemical reaction. So therefore, according to the modern definition, the valency is the number of electrons that an atom can lose. That is, it can give it to somebody else, or it can gain from somebody else, or it can share with somebody else during a chemical reaction. Now, valence electrons is equal to the electrons of the outermost shell. Okay, an atom loses electron, then the atom becomes positively charged ion, or it's known as cation, if it loses electron. That means the negativity becomes less than the positivity of the electron, of the atom. An atom, if it gains electrons, then it is negatively charged ion. Okay, and that is known as an ion, because what happens when it gains electron? Its positivity decreases than the negativity, and therefore it's negatively charged ions. Okay, now atom can be monovalent, divalent, trivalent, tetravalent. That is, it can have a valency of 1, 2, 3, or 4, etc., 5, 6, 7, 8, like that. Now, metals generally has 1, 2, or 3 electrons in the valence shell. Some non-metals like C, carbon, some metalloids, silicon or germanium, and rest are metals and 4 electrons in their valence shell. So some non-metals like carbon, some metalloids like silicon and germanium, and rest are rest are metals which has 4 electrons in their valence shell. Like carbon, carbon has 4 electrons in its valence shell. Some metalloids like silicon and germanium, they also have some 4 electrons in the outermost shell. And the rest is the metals which have 4 electrons in their outermost shell or valence shell. Now, generally non-metals have 5, 6, or 7 in their valence shell. So 1, 2, and 3 always metals. 4, it's carbon or a metalloid like silicon, germanium, or some metals. Okay, some rest of the metals other than 1, 2, 3 electrons. Okay, and some non-metals, generally non-metals have 5, 6, or 7 electrons in their outermost shell. Next is the valency and the noble gases, they have 8 electrons on their outermost shell. Now, the valency of an element or of a radical is the number of hydrogen atoms that will combine with or displace one atom of that element or radical. HCl, HOH, that is H2O, and etc. So the valency of an element or of a radical is, what is that? It is the number of hydrogen atoms that is combining with or displaces one atom of that element or radical. Okay. Then some elements exhibit more than one valency. Okay. So you understood the valency of an element or a radical. Okay, the number of hydrogen atoms which is combining with or displacing one atom of that element which it is combining, or it can be combining with a radical also and displacing one atom of that radical. Okay, like HCl, chlorine is combining with hydrogen. With how many hydrogen atoms it is combining with? Okay, the number of hydrogen hydrogen atoms which is combining with chlorine to form HCl, that is to form HCl, combining with it and displacing how many atoms from chlorine. Okay, like that H2O also. Now again, some elements which have variable valency, that is more than one valency if it has. Then when an atom loses more electrons than that which are present in the valence shell. Okay, we know that the atom loses or gains electron in its valence shell. Okay, what is there in the valence shell? But if it loses more electrons other than the valence shell, also from the penultimate shell, that is, then it exhibits variable valency. When an element exhibits 2 positive valencies and then lower valency suffix is as, higher valency is suffix is ik. Okay, if it has 2 positive valencies, like iron has suffix as for ferrous, that is 2 positive ions, 2 positive valency, valency is 2. And if the higher valency, if its valency is 3, then it is suffix is ic, IC, ferric. Okay. According to the modern chemist, it is represented by Roman numerals. Like this is tannum chloride, tin chloride. The tin, it has, see, we can write a Roman numeral around beside tin, that is 2. Roman numerals 2. Okay, and then see that is tin chloride, this is 4 valency, we write here as 4 in Roman numerals. See from the table you can see cuprous and then cupric, or copper 1 then copper 2, mercurous, mercuric, mercury 1, mercury 2. Okay. Then ferrous, ferric, iron 1, iron 2, iron 3. Then plumbus, plumbic, lead 2, lead 4. Stannous, stannic, stannous, tin 2, tin 4. Orus, auric, Orus 1, that is gold 1, gold 3. Like that, the higher valency has ik as a suffix, and the lower valency has a us as a suffix. That this was a previously done, but now according to the modern chemists, they write it in this Roman numeral way. Okay, now nitrogens has 3 and 5 valencies. Phosphorus has 2 and 4 2, 4 and 6 valencies. So even non-metals do exhibit some different variable valencies. Okay, next we come to formula. Now it is for what is formula? It is a symbolic representation of a molecule of an element or a compound. Okay, it is also known as chemical formula. Okay, so formula is nothing but it's a symbolic representation of a molecule, of an element or of a compound. Symbolically it is represented. Okay, that is with symbols. If we represent a molecule of an element or a compound, that is known as the formula. Now, what is the significance of a formula? If we write a chemical formula or simply a formula, then it represents both the molecule and the molecular mass of a compound. Okay, this formula, chemical formula, represents the molecule and the molecular mass of a compound. Also, it shows the respective numbers of different atoms which are present in one molecule of a compound. Okay, it shows the different atoms, respective numbers of the different atoms which are present in one molecule of a compound. It also denotes the ratio of the respective masses of the element present in the compound. I'll explain this with an example. See, the formula, say, for carbon dioxide, we write it CO2. Okay, so this is the symbolic representation of the carbon dioxide, one molecule of carbon dioxide. Okay, now each molecule contains one carbon and 2 oxygen atoms, which are joined by chemical bonds. Now, the molecular mass of carbon dioxide is 44, and given that the atomic mass of carbon is 12 and oxygen is 16, we know that the atomic mass of carbon is 12 and oxygen is 16. So if we add them up, the molecular mass becomes 44. Okay. That is 16. If see from the formula CO2, so C is 12, then plus oxygen, that is 2 atoms are there, so 2 into 16, that's 32, plus 12, that is 44. Okay, next is we come to radical. Now see, radical, it is an atom or a group of atoms of the same or of different elements that behaves as a single unit with a positive or a negative charge. Okay, so radical, till now we have studied a single element having a formula, that is having a symbolic representation. Then we come to now radicals. Radicals is, it may be single atom or it may be a group of atoms of the same element or of different element, which behaves, but they behave like a single unit. Okay, with having a positive charge or a negative charge. For example, see, molecule of KCl, that is potassium chloride, has 2 parts of potassium and chlorine. Okay, so these two are different radicals. Potassium and chlorine, these two are different radicals. Potassium is a positive radical and chlorine is a negative radical. So it's a one atom. Now magnesium sulfate, 2 parts are there. See, magnesium and sulfate. So magnesium is a single atom, but sulfate is a group of atoms. Okay, but behaving like a single unit, having a positive or negative charge, but here sulfate has a negative charge and magnesium has a positive charge. Okay, so this sulfate is a radical, magnesium is also a radical. Now see, Potassium has a positive radical, I told you, and sulfate has a negative radical. As a compound radical. It's a simple radical is potassium, and sulfate is a compound radical. Now note, an acid reacts with the base to produce salt and water as a result of neutralization. If we react potassium hydroxide and base with an acid, that is, for example, see, so this hydrochloric acid, then we will see a salt and water is formed. Salt is what here? Here it is potassium chloride and water is formed. Now, potassium hydroxide is a base and the basic radical is potassium. That is electropositive radical, or you can say cation. Okay. Now, HCl, that is hydrochloric acid, it's an acid, and chlorine is a acid radical, and it's an electronegative radical, and this is known as anion. So potassium is a basic radical, chlorine is a negative, acid radical. Okay. Now the radicals have their own valency, and accordingly they form chemical formula. Okay. Now the radicals, they have their own valencies, and they behave accordingly. They form the chemical formula. For example, see, ammonium carbonate. Okay. Now, where ammonium, that is NH4, ammonium behaves as a basic radical having the valency of 1. Okay. And the carbonate is an acid radical having the valency of 2. Okay, understood? Next, we are coming to how to write a chemical formula. Now, for this, we need certain steps to be followed. Writing the symbols, we need to write the symbols side by side, first the basic and then the acidic radical. Okay. Now, after writing the symbols side by side, we write the valencies of each atom on the top of its symbol. See, from the example in the slide, we come lower down. See, this is the calcium oxide is the formula. Calcium oxide is the compound. We are writing the formula as CaO. Now, Ca, that is calcium, we write the basic radical and then the acidic radical. Okay. So calcium has 2 valencies, positive valencies. Okay. And oxygen has 2 negative valencies. We ignore this positive and negative sign of the radicals. Okay. Now, after dividing by HCF, that is highest common factor, it becomes, see, both of them has 2 valencies. So we divide by the highest common factor and it becomes Ca1 plus and O1 minus. Okay. Now we exchange their valencies. Okay, so interchanging the valencies, calcium becomes the valency of O1 and O1 becomes the valency of Ca1. So the formula will come to the CaO. Okay, so after interchanging the formulas, okay, we get the formula as CaO. Writing the interchange valencies numbers in the lowest right of the radical. If the radical is a group of atoms, 7 has a valency number more than 1. Okay, enclosing it within the parenthesis. Okay. Okay. So I'll stop here. I'll discuss in my next video. I'll continue with this writing the chemical formulas with certain other examples. Okay. So please go through this. If you have any doubt, please do write in the comment box. Do share with your friends so that they can also be benefited from these videos. And as I told you that I'll be discussing some ICSE pattern questions of this class 9 only of ICSE syllabus. So for that you need to subscribe my channel so that you can get the notifications of my next video. And also you need to stay tuned with me. Okay, so have a good day and happy puja to all of you. Okay, Thank you. Thank you, viewers.